Today, we're going to discuss cured and smoked foods. In Chapter 5, we talk about four basic preservation techniques. We talk about curing and brining, smoking, drying, and preserving in fat. When we are looking at preserving foods, an important part is the ingredients used. The basic ingredient used to preserve food is salt. Salt actually plays a very important role and does four things during the preserving process. It per, it starts osmosis, it helps with dehydration, it helps to inhibit and control fermentation, and it helps with denaturing of proteins. So, a science lesson today will start with osmosis. So, osmosis is the movement of a liquid like water through a membrane or cell wall to equalize the concentration. So, what is happening is by nature, we want everything in equilibrium. We want the same amount of liquid on both sides of a concentration. And so, what will happen is if something on one side is drier than something on the other, through osmosis, it will allow that liquid to go to the through to the other side, so everything becomes in the same level, and so they're both equal on both sides. So what happens is when you put salt on an item, it dries up the outside of the item, which helps to open up the membrane to let moisture out. That's why when you put a dry rub on like a pork butt, it's dry to begin with, but after sitting for a while, you'll notice it starts to turn into a paste because the natural moisture is coming out through osmosis. But by doing that, it also draws in the salt and other seasonings into that product. That's why we see that flavor profile and that color going in further than just the outside. Now, for something that's a dry rub, it's going to take a little bit for osmosis to bring it in as far as it can, which is why when we do a wet rub or a brine or a cure, we will sometimes inject it to help speed up the process of that osmosis to help it along to make sure that the entire thing is cured. When the salt gets into the cell, it helps to kill off bad bacteria and helps to make that product safe to eat and also extends the shelf life. Dehydration is another important part, and it works to partially with osmosis. When you apply salt to food, what it does is salt attracts the liquid or the moisture that is there, and it makes it unavailable to microbes. So if the salt absorbs the extra water, bacteria does not have that access to the water, which in essence then makes it tougher for that microbe to live. So couple that with exposure to air circulation and or heat allows that water to evaporate out, and it results in the less volume and less weight of food. That's why when you put something in a dehydrator, it's going to pull the extra moisture out through the movement of the fan of the air that going across it and the heat that's in there to help get rid of that extra moisture to again make it an inhospitable environment for bacteria to want to grow. So fermentation is a big part of we see in a lot of curing processes. It breaks down in the compounds into gases and organic compounds. If you just let the enzymes work their magic and keep going, it's going to pretty much break down the entire food into nothing. So what salt does, it acts to be a control in the process. So it affects how much water is available for those enzymes. So it says, oh, okay, you've used up all you can. There's no more extra water, so you can't work your magic anymore. It's also like for baking, why you got to be careful about adding salt to yeast, because it will stop the process of yeast working its magic. We say it kills the yeast. It's getting rid of the extra water and stuff for the yeast to actually work its magic. So in this case, salt does not help fermentation. It controls the fermentation so it doesn't get out of hand. last but not least, salt helps to change the structure of protein while it's in the food. So what it does, if you remember back in 150, we talked about proteins kind of being like springs, and so they're very, very open and stretchy, or when you apply heat, it compacts and it tightens them up. By using the salt in such a way, plus during drying, it actually helps to change the structure of that protein to make it last longer. Again, biggest example is beef jerky. By marinating it and then drying it out through the dehydrator, it changes the way the proteins are made up. They're ready to eat because we've dissolved the extra water and we've gotten it, and so the proteins have tightened up to the consistency that we are looking for. In addition to salts, we also look at curing salts for preserving foods. So these, like everything else, were pretty much found by accident. Unrefined salts typically have traces of curing salts, nitrates and nitrites. What we have done through science and technology has been able to separate those out so we can get a consistent product every time. When you're working with unrefined salts, they didn't necessarily have a certain amount of either of those in there, and it could vary from one thing of salt to another. Now we have the ability to control them. The difference between the two, nitrates, or the NO3, take longer to break down, and those are used for very long cured products. Nitrites, NO2, they break down faster, and so they are used for cured items that are usually going to be cooked later. So for example, the TCM, which we'll talk about in a second, that you use for your bacon and your hams and all that, those were all nitrites. Those are ones that break down faster and they help with the curing, but you're going to do some cooking of them. If you're going to do something like a Serrano ham or a Smithfield ham or something that cures for 9 months or more, you're going to utilize nitrates in there as well as the nitrites, because the nitrates are going to work long term where the nitrites work the short term. Something you do need to be concerned about is what's called nitrosamine. So nitrosamine is when a nitrate or nitrite breaks down in the presence of extreme heat. So example, bacon cooking. It releases this potentially dangerous substance. It was discovered to be carcinogenic back in 1956. Because of that, it's very closely regulated on how we use our nitrates and our nitrites. However, studies have been done to try to find alternatives for nitrates and nitrites to help cure foods, and there has been found no other substances on Earth that work as effectively as nitrates and nitrites to help reduce bacteria growth to keep food safer longer. So the most common nitrite blend is known as tinted cure mix, TCM for short. It might be called pink cure or known as Prague powder 1. And this is a blend of 94% sodium chloride, which is the fancy name for salt, and 6% sodium nitrite. So we've got those set up as the base for you to use when you are curing bacon or hams, things along those lines. The reason why it's colored pink is just for identification reasons. It's so we can know that, hey, this is just used for curing. It's not meant to use to season your product, because the last thing you want to do is be putting TCM while you're seasoning your product, especially thinking it's like Himalayan pink salt or something along those lines. So you do want to keep it up so people are not accidentally using it for other purposes. So check this out. The recommended ratio, 4 ounces of TCM will cure 100 pounds of meat. Now, break that down. 4 ounces of TCM does 100 pounds of meat. If 4 ounces of that 4 ounce TCM, 94% of it is salt and only 6% of it is sodium nitrate, that means that pretty much 0.25 ounces, about a quarter of an ounce rounded, of pure nitrite cures 100 pounds of meat. So you can understand why we use it as a ratio of TCM, because if you do, it's supposed to be 0.25 and you do 0.5, you're doubling the amount, which could be bad for some people if you're doing straight nitrite. Well, if you do 4 ounces, you end up doing 5 ounces. Yeah, that's not great, but it's not going to be as detrimental. So the nitrite itself is really potent, and that's why it's blended with the salt to help negate the issues of potentially making somebody sick because you're using too much. So that recommended ratio of 4 ounces of TCM to 100 pounds of meat, and knowing you're using 0.25 ounces is all you're using for that 100 pounds of that nitrite is pretty crazy to think about. The Prog Powder 2, which is kind of the general name, you might see it referred to as like SureCure 2 as well. That is your nitrate for doing long cures. And so those contain salt and the pink coloring, sodium nitrate and nitrite. It contains both, because what you do is you want those sprinters of the nitrite to get the process started. And then the long distance runner, the nitrate, takes over, and there's a slower process. By the time the nitrite is done working its magic, the nitrate is really at full stride. Again, these are for dry or dry fermented products. So different salamis, not fresh hams, but Serrano and Smithfield hams, things that have long curing times. We won't use any of this in this class. We will just be using the TCM because we have those shorter curing times. You might also find some places use cure accelerators. Some fun words: sodium etherbate, sodium ascorbate. These are used to help with enhancing colors. So a nitrate or a nitrite helps to give a natural pink tinge to the finished product even when cooked. So for example, corned beef is typically done with nitrites. The reason why cooked corned beef is pink and not gray like a normal roast would be is because of the nitrites that are in. Some manufacturers will add these cure accelerators to help with the color retention. So it helps with make that pinker and helps with some flavor retention. They do have some reddening effects like nitrates and nitrites, but it's just a temporary thing. It doesn't have long-term like the nitrates or nitrites. They are used as an accessory to those curing salts, but they are not a substitute for those curing salts. So if you see sodium etherbate or sodium ascorbate on a product, especially like a corned beef or something along those lines, those are accelerators working in conjunction with the nitrates and nitrites. Another interesting one is your hot dogs, your frankfurters. If you think of the color of like a bratwurst, when it's cooked, it's going to be gray, like you would typically associate brown on the outside because you probably grill them, but the inside is gray from the cooked meat. Well, a hot dog is not gray on the center. It has that peachy, almost pinkish type color. It's because of the nitrites that are in that sausage blend in order to give you the color that you're looking for. A little tidbit of information there for you. So in addition to the curing salts, the salts, maybe the enhancers, then you have seasonings and flavorings. Sugar is probably your next biggest category, your sweeteners, because that helps to offset the salt that's being used. And you have different varieties: dextrose, corn syrup, sugar, honey, maple syrup, and of course agave is another one. Those are going to add different flavor profiles because they're sweet, but maple syrup and honey are two different flavors of sweet. Sugar is a different flavor of sweet. Dextrose is a real concentrated sweet compared to sugar. So depending on what you're looking to get from a final product flavor-wise will maybe make a difference as far as the sugar that you'll use. Spices and herbs and other items, some of the more common ones are cinnamon, allspice, nutmeg, mace, cardamom. Of course, dried or fresh chilies, sweet or hot. Infusions or essences. So taking liquids and infusing flavors into them. Wines, fruit juices, or vinegars, you just got to be really careful the pH with those, especially if you're looking at sausages to do with these, because it can make a difference in the texture, which we'll talk about in the next chapter. But those are all possibilities as far as flavors that you can add when you are curing products for long-term storage. So let's talk terms. So cures and brines. So cure is actually a generic term to indicate any type of long-term storage of products. So it could be a liquid brine, it could be a pickle, or it could be a dry cure. So it's kind of the catch-all name is what a cure is. If you add salt and you apply it to food or a dry product, then you've got a dry cure. If you take that dry cure and you add a liquid, then you've made either a brine or a pickle. All right. Once you've cured or brined it, then you might hear them referred to as cured, brined, pickled, or corned. A salt brine, just salt water, can be known as a pickle. Just because it's a pickle, it does not mean it has to have vinegar, although a lot of times that's what we associate with our pickles, is a brine with vinegar added to that, even though, again, it doesn't have to be the case. A dry cure could just be salt, although most of the time it's salt, sometimes sweetener, and then flavorings, and then maybe that TCM. It's packed and rubbed over the surface of the food, and it needs to be in direct contact to allow osmosis to work its magic to pull the cure and the flavors and stuff into the meat itself. And then from there, it may be smoked or baked or whatever needs to be done after it's allowed to cure. You take that cure, dissolve it in a liquid or a brine, in water. It's known as a brine or a wet cure. There are two basic ways to brine. You can do a brine soaked or injected brine. A brine soaked is where you just submerge the food in the liquid. Those are good for smaller items. If it's a larger item, you usually want to do an injecting brine. And that's where you take and you inject up to 10% of the weight of the item with the brine. All right. So if you have a 1 pound item, you take 1 pound times 10%, or 16 ounces times 10% is the easiest way. Then you end up getting 1.6 ounces. So round that up to next quarter. So you take 1 3/4 ounce and inject that into the brine. Into the meat, brine into the meat. The reason why we don't do more, it's actually an FDA code, and it's to prevent unscrupulous processors from trying to get more bang for their buck. Because we know water's pretty heavy. A gallon of water weighs about 8 pounds. So the basic equivalent, give or take, for water is 1 pint of water weighs about a pound. Well, if I sell my meat by the pound and I'm injecting it with brine or water, guess what? That increases the weight of that meat, in quotes. Right. So if I'm doing more than 10%, I'm adding more brine or more water, which is increasing the weight. So I get more money from it, but I'm not getting more meat from it. I'm getting more liquid. And so that's why it's controlled, just to make sure people are not abusing that system. But for the fresh hams that we're going to turn into hams, we're going to weigh those bad boys out, find 10%, and then we're going to inject them with the brine so we can cut down on the curing time. The basic formula for doing a brine is equal parts sugar and water, about 1 pound of each, 4 gallons of water, and then a gallon of ice. So you heat the gallon of water, add the salt and sugar, any other flavorings, make sure you heat them to dissolve, then add the cold water and ice to chill the brine so then it's ready to go. You never want to add food that you're going to brine into a hot liquid because you don't want to cook it. You want to keep it cool. So please be conscientious about that. Some information as far as for brining. So you check it out. So a whole chicken, if you just submerge it, it's going to take a day to a day and a half. By injecting with 10%, you knock that down to 12 to 16 hours. Get down to the ham. So you go from 6 days to 4 days. If you do a bone-in ham, it goes from 20 to 24 days down to about a week. So in brining with injection is definitely a positive thing to do as far as helping to reduce those brining times that need to have before you move on to that next step. And this is all in your book, by the way. Okay, now we've got our stuff brine cured. Probably the next big thing is now we're going to smoke it as part of our cooking and curing process. When we are smoking products, all smokers have these four features. You have to have a way to create a smoke source. You have to have a chamber for the food to be exposed in. There has to be some sort of circulation of the smoke in the chamber. And then you got to have a way to vent the extra smoke when it's all said and done. And there's many different ways about doing this, many different styles, and everyone is going to have their favorite way of working with a smoker and their favorite type of smoker. Looking at things for smoking, any hardwood is fair game. So you can see hickory, oak, cherry, walnut, chestnut, apple, alder, mesquite, citrus fruit trees are all fair game. Some other options, dried tea leaves, herb stems, spices, grapevines, corn husks, fruit peels, and peanut shells are all options that you can use as far as smoking. What you want to avoid, though, are wood that comes from a softwood like an evergreen or something that does not lose its leaves, because it's going to have a lot of sap, which is going to give an acrid smoke when put into a smoker. You also want to avoid, of course, pressure treated woods, because those have chemicals that when we release those would not be very good for people to ingest. So don't go to the local construction site and pull some pressure treated lumber out of their scrap pile and use that to smoke. That's not going to be a good thing for you or your guests. Before we can start the smoking process, we need to form a pellicle. Pellicle is a tacky outside skin. It helps to allow the smoke to adhere to your finished product. The way you do that is you take off your plastic, your covering, and you let it air dry in your refrigerator, so that air moving across pulls a little bit of the extra moisture, and that tacky skin helps to capture that smoke flavor or color. If you don't do a pellicle, sometimes you will find, because of the extra moisture, that you'll get streakiness in your finished smoked product because the smoke doesn't adhere well, because the moisture is pulling some of that pellicle off, or some of that smoke color off of there. So it's something that I always recommend, especially when you're looking at a good visual product. When we look at smoking, we have a few different types. First is a cold smoke. A cold smoke is something where you're wanting to add smoke flavor, and you're going to cook later, or something that's already cooked that you just want to add flavor to. Typically, it's done at 100 degrees or below, with commercial cold smoking being done at like refrigerator temperature, where you have a smoke source that's being vented into like a walk-in cooler type of setup where it's at 40 or below, and that smoke is allowed to penetrate the food that's in there to get those flavor profiles. The other thing you can might look at is if something's going to be air dried, is another thing that you might do a cold smoking as well. So you could do a smoked shrimp where you cold smoke some shrimp and then saute them up to add a smoky flavor. Yeah, of course, if you have any smoked cheeses, those are all cold smoked because you don't want to heat up the cheese and melt it. You could do a cold smoke to something like if you wanted to do a smoked peach salsa. You could cold smoke the peaches and tomatoes before you dice them up to put in for that salsa. So there's a lot of different possibilities, but the biggest thing is you're adding the smoke flavor, but not cooking. Hot smoking is typically between 165 and 185. You're controlling the smoke and the heat, and when done right, they are fully cooked and they are ready for you to eat. You don't have to cook them any further. Smoke roasting is known as barbecuing. So those that like to barbecue, your smoke roasting is the technical term. Typically, those are things that are 250 and above, is when you get into that smoke roasting. Another option is pan smoking, where you actually take, for me, a disposable pan to add a smoke flavor. So like 2 disposable aluminum pans. When I was at Lindsay's on Liberty, we used to do that with our salmon. We would take a aluminum foil pan, we would put some we put some wood shavings in the bottom, put a rack on top, and then put our pieces of salmon, put a the other aluminum foil pan on top of it, and then put it on the stove top and let it heat for about 10 minutes or so. The problem with that is you don't have much control over the smoke and the flavor. Your only control is how long you actually leave it on the heat. You don't have as much, and it's definitely cooking all the way through. If you're going to do this, please make sure you're doing it either outside or in a kitchen that has good ventilation, not your ventilation from your home vent in your kitchen at home, but like commercial ventilation, because you're going to pull out a lot of smoke, and you want to make sure that you can draw that out so it doesn't get out of your kitchen area. So sometimes you'll need to find where items are air dried. With air drying, the big thing is making sure you're getting that balance of temperature and humidity. Our curing cabinets in the middle kitchen are great examples of something for air drying. Typically, ours are set at 60 degrees with 60% humidity, which is about like an equivalent of a cave temperature. Is kind of that was old school. They'd be in cellars or caves where the temperature was consistent all year round. So some items that you can see, the Serrano hams, Smithfield hams, prosciutto, air-dried beef, braciola, beef jerky are all some examples of air-dried items. Finishing up then is preserving in fat, and this is a very classic where of preserving food. So you would take the product, cook it in fat, and then save it in like a ceramic crock with fat on top to act as a lid. So there's two different types, confit and rillette. For a confit, you would take the product, you would simmer it in fat, and then you would cover it in the fat. So one of the classics is duck confit. You take duck legs and thighs, and you cook them in your rendered duck fat. So you take the fat, heat it up so it pulls the liquid fat out, and then you would very slowly cook those legs in that fat. And then, like for us, we would put it into a Cambro container and then cover it with fat. When the fat sets solid, it acts as a lid and seals out anything. And so old school, they would then put those in the pantry, and then they'd be able to hold those until later down the road, and they can pull them out, and you've got a lot of protein and fat that would help with people's diets during the winter time. For a rillette, you would take usually a bone-in piece of meat like a pork shoulder, and you would stew it with vegetables like mirepoix and other aromatics. Then you would take that cooked meat out, you would shred it, and then you would mix it with the liquid fat, the rendered fat, and it makes it into a paste. So it's like a spreadable thing that you could put on crackers and such. You would take that paste that you make, you pack it into containers, cover it with a layer of fat, and then once it sets, again, it acts as a seal, and then you can pull it out, and then they can use it as a filling, or they could use it as a topping, again, adding protein and fat for the guests at that time, again, especially in the winter when food sources might be more scarce. Hope you enjoyed the information on Chapter 5. Please let me know if you have any questions, and I'm looking forward to what you guys create and how your things turn out. Thanks, everybody, for watching.